Welcome to Robotics and Autonomous Systems, lab number 1. So this is actually a follow-up to the lab that we had physically. So in this particular session or recording, I will basically walk you through on how to install and set up MATLAB Robotics Toolbox in your MATLAB software. And also Robotics Toolbox will be the primary platform that we'll be using in this particular module. Right, and I will also explain why that is the case later in the session. Right, so I will share this sheet with you in the course web. So, but for the time being, I will just guide you on how to do it by doing it by myself. Right, so you can go to Google and you can just Google Robotics Toolbox by Peter Koch. Right, so you have to make sure. So if you go to MATLAB here, and if you go to home, and if you go to add-ons, and if you go to manage add-ons, right? So there is already a toolbox installed by MATLAB, right? So that is not the add-on that we will be using, right? So if you go down here to robotics, so you can see that there is a robotic system toolbox. Yeah, the author is MathWorks, right? So this is not what we'll be working with, right? So this is separate environment, separate add-on. So this is not what we'll be using, right? So you can go to Google, and you can, once you Google, you will get this particular tab on the top. I mean, this particular link on the top. You can go here, and you will be redirected to this particular page, right? So here, so Peter Koch is a professor of the Queensland University of Technology, as I remember. So he has developed this particular toolbox, which we can use to develop and model robots. Not only model, but also do certain application-based tasks like trajectory generation, part planning. All these things can be done. So so what you can do is you can just go to downloads here, and if you are interested, you can just read through, right? It's a lot of applications that you can sort of see here and all. And Peter Koch himself has provided some guidelines. So what you can do is you can go here, go down here, right? And there's this this file, this MLTBX type file, right? So what you can do is you can download this, right? So this is the easiest way that I'm saying, right? There are multiple ways that you can download and set up MATLAB Robotics Toolkit. You can go to GitHub and download. You can sort of run two functions. I think there's a M file that you can download and run. So there are different ways. So I'm just telling you that it's the easiest way, right? It's up to you to decide on how to set this up. So you can just go here, download this MLTBX file. So it will take some time, right? So once this is done, right? Once this is done, so I'm not going to wait until it is done. So you can just go through once the installation process, once the downloading process happens. So I think I have this file already stored somewhere. Sure. Yeah, so this is there. So I will, since this, I just cancel this, right? Because I already have it. So you can just click on this, and basically you can, I will just put this on the folder. Right, so I will basically open this. File, right? So basically once it's done, so in my case, it doesn't have to get installed, right? So I already have installed this. But if in your case, it will get installed from the beginning. It will take a little bit of time. So So once this is done, you can the documentation will automatically open up, right? But if not, still you can still go here to as I mentioned earlier, you can go to home, you can go to add-ons, you can go to manage add-ons here, and then under install category, you should be able to find this robotics toolbox for MATLAB. And please make sure that you check the author, right? It should be Peter Koch, because there's another MATLAB toolbox, robotics toolbox, which is by MathWorks, right? So this once again is not the correct version, right? This is once again default robotics toolbox that comes with MATLAB. This might vary based on your installation, based on the version that you're using. So there could be, you might probably not have any robotics toolbox, which is actually very unlikely. But it's most likely you will be having these robotics toolboxes by MathWorks, right? So, but what we require here is the Peter Koch's version, right? So once this is done, you can simply the details and all these things. But if not, what you can do is to check if this is installed. You can simply go to your command window here, right? You can go to your command window here, and you can simply type startup underscore RVC, right? Or first we'll go with RTP. So there's two toolboxes, right? If you go to add-ons, you can see that not only two, there's multiple toolboxes installed. So there's basically three toolboxes, right? This visualize is actually coming as a part of this, that we can visualize certain aspects of the software. And this polynomial spirals is like used for trajectory generation. So don't worry about that. These will not should be used, right? But in our case, so you can simply run this RTB first, right? So RTB is for robotics toolbox, and once you run it, it will say it's installed, right? So that is fine. And also you can make sure that you have startup underscore RVC. This is for the robotics vision control. So so simply you can see that it is also found, right? So so you don't have to worry about this. These things, it says that these are at least 2 years old. Don't worry about that, right? So, and also it says that these functions, right? These functions are shadowed by this particular add-on, the polyspace add-on, right? So I will show you a fix for that. So we will see how that becomes a problem, right? We will see how that becomes a problem as we move on. So once this is done, if you want to like go for and check for a demo, you can like type RTB demo and you get a demonstration of the robotics toolbox, right? So so there are different things like, so robotics toolbox is a platform. I mean, so why we use robotics toolbox is another question, right? So when you talk about simulators, right? There are multiple simulators available, especially for robotics, right? So, and selecting the most ideal simulator for our tasks depends on certain aspects. First up, it's like it's based on the characteristic or property that we are trying to simulate, right? So imagine you want to simulate a robot. So you want to design a robot. So you want to design a manipulator. So in this particular module, the first few weeks mainly, I mean, not only the first few weeks until week 7, week 8, you will be focusing on the design aspects of a manipulator, right? So you'll be talking about now we'll be talking about spatial descriptions, transformations, so that we can identify the relationship between links and joins. And then once again, it will be extended towards something called the DH parameters, and then how to model a robot using forward kinematics, how to control a robot or navigate a robot using forward kinematics, inverse kinematics. Then we will go into areas like Jacobians of the robot and then the trajectory planning of a robot. All these things are basically connected with the design of a manipulator, right? So these design aspects of a robot can be simulated using robotics toolkit. Basically, the mathematical modeling part of a robot, right? But there could be other aspects that you try to focus on when designing a robot. As an example, you probably might need to do a dynamic or a kinematic study of the robot when you're trying to model. As an example, say you want to see how the torques vary, how the or if not, you can maybe check how a payload will affect the static elements or the static aspects of the robot, right? So for these, you probably might need different simulators. For those aspects, Robotics Toolkit is not, it's not an option. You don't have those features in Robotics Toolkit, right? So for multi-body dynamics, you probably might need a software like Adams, right? I think you all have done it earlier. For static analysis, you probably might need a software like, say, Abacus or ANSYS or something like that, right? So like an FEA, a finite element analysis based software. And also there are other aspects in robotics, like so like also the type of the robot, right? So based on the type of the robot, also the simulator might vary. So imagine you are going to use a manipulator, then of course you can say you can develop the design the manipulator, plan the trajectories and all these things in Robotics Toolkit. But sometimes the visualization of Robotics Toolkit might not be enough. It might not give you a practical sense of robot control, right? So for those aspects, because it's much more of a mathematical modeling type environment. So there are other softwares that you can use. So one software is RoboDK. So you can, once again, it's not a free software, right? It's not a free software. It's I think you have to purchase a license, but still there is a free version. So for 30 days anyway, you have the entire software for free, but after 30 days, you probably will have some features which are free, right? So robotics, RoboDK, I will do a separate session on RoboDK, but so you can see the software here. So basically you can just open up this tab, and there's all sorts of manipulators that you can download, right? There are certain manipulators. You can simply select a manipulator of your choice, right? And so you can specify the type of manipulator as well, the brand and the type, right? So basically, if I go for a Nanook arm and say number of axes, I'll say specify as 6. So we got multiple arms here, right? We can, so my connection might be a bit slow. So you can see there's a lot of arms, right? So if I go with the one that we have at the university, so I can just go and download this, and it will open up in our environment, right? So this is the environment. You can do all sorts of programming, just for timing, I will just jog it manually. So you can, control the arm, you can write programs and do all sorts of things, right? This is possible. You can so control the robot using, you can set certain, control methods here. So you can go for tool frames, reference frames, and also you can manually jog the axis, I mean, from the joints, right? So all these things you can do. I mean, these are not the things that we will focus in. These are simple tasks, but you can, you can do all sorts of trajectory planning and all these things in Robotics for any arm, and you can generate the program, and then you can implement that in your physical manipulator, like the real world manipulator, right? So I'm at the moment I'm using the free version. So you can if you want, if you require, you can get the license and you can use it, right? So you can see that the visual sense that you get from the simulator is much more different compared to the robotics toolkit. You will see in the future how the robotics toolkit designs are. But this actually doesn't give an overall overview of the mathematics behind this, right? The relationships. It's more of like a real world simulator, right? So that's what I say, that based on different elements of your interest, the simulator might vary. And also, manipulators are not the only types of robots available, right? There are other types of robots. So there's mobile robots. And under mobile robots also there are different types of robots. There are UAVs. There's legged robots. There's wheeled robots. There's humanoids. Then we have this underwater robots, amphibious robots, right? There's multiple types of robots, and also the robot control methods, like it can be semi-autonomous, autonomous, and then it can be teleoperated, right? Telepresence robots. There's so many types. So based on all these types, the control mechanism also would change, right? And also the simulation types might change. So another simulator that we can use for certain applications, this is actually used for multiple applications as well. I introduced this Coppelia Sim simulator for RoboFest year before last, right? Because RoboFest was happening virtually. This is open source. This software is open source, and anyone can download it freely and use it. And also you can make your own environments here. And you can simulate these robots, right? You can simply, there's a wide variety of robots here. So these are mobile robots. Mobile robots means robots which can move from place to place. And also there's non-mobile or fixed base manipulator type robots, right? Basically, there are some delta type robots, parallel robots as well, like these. And also there are other types of robots. If I take one robot here, and maybe I will show you. So this is the ABP IRP type robot. So basically, this robot, you can simply program it, but one of the shortcomings not shortcomings, I'd say, but one of the drawbacks is the default language these robots are programmed in is Lua, right? It's a type of language. It's not very popular, but you can use APIs, right? You can use APIs like MATLAB, Python, C++, and program these robots. So if you all are interested, I can maybe provide some resources on how to set up an API in Coppelia Sim, formerly known as VREP, and simulate these robots, right? It's up to you, but it's not required in our program as for my knowledge, right? So our basic focus will be on robotics toolkit. Okay. So a robotics toolkit also has its own mobile robot applications, right? So it has this V-star navigation, so you can do mobile robot navigation in robotics toolkit. Basically, any type of mathematical or probabilistic robotic application you can do in robotics toolkit, like mobile robot navigation. And also you can have this trajectory planning and all these aspects as well. And it has a VREP API, like like a bridging also, which we will not discuss at this particular time, but we can maybe, if required, talk about that as well in the future, right? So you can sort of try these things if you are interested and see how this works, right? So so I will show you this. There's a command here. So once it's set up, you can maybe simulate a drone. So you can simply type SL underscore quadrata, and the simulating model for this will be built, and you can run this, and the default program will run. And some error, I think. So yeah, for some reason it's working for the time, but you can basically run this, and you can get a quadrata to operate, and then you can maybe basically change the functions here, and like control the quadrata and do all sorts of operations, right? Right. So that's about the background of the software, which I'm not going to waste a lot of time on, right? But if I get back to what's important, so so if you want to check, there's something that you have to check once this is done, right? And that is, I had to close the demo. I think that was the problem, basically. Now, if I run the simulator, should it run? I think I'll have to once again load the quadrata, but it will take a lot of time, so I'm not going to do that. Loading this simulating model from the MATLAB command window takes some time, but if you want to try this, you can simply type this here in the command window, and if your Robotics toolkit is installed properly, this will load up, and you can simply run it and see the animation. But what we are not mainly concerned about the animation, and we can just control this. We can vary these elements and see how we can control the UAV. Once again, this is out of the scope of this particular module, right? Because we are mainly concerned about manipulated modeling. So to check certain aspect of the software, you can simply type rot x IO2. So this is basically the rotation matrix. We are trying to get the rotation matrix around the x-axis by an angle of IO2, right? So by 90 degrees simply. So the default angle, the measure of the angle that's being used is radians, right? Keep that in mind. So sometimes people use degrees for this, and then they mess it up, right? So what you can do is you can use radians for the angles, right? So once you just type this and run it, if you get this answer, it's wrong, right? It is not the expected answer, right? The expected answer, if you like manually calculate the rotation matrix around x for an angle of 90 degrees, you should be getting 1, 0, 0, 0, 0, minus 1, 0, 1, 0. That should be the answer that you should be getting. So the reason for getting this answer is because this particular shadowing, right? Because these rotational matrix functions are shadowed by these polyspace functions, right? These phased functions, these phased array functions. So to fix this, what you can do is, so you can try this and see. So if you are getting the exact answer, then you don't have to worry. But if you're getting this is wrong, so you have to fix this. So you can go to a set path here, right? You can go to set path. There are two options that you can try. I will show you the one that is most safe, right? I can't say safe, but this is. I will first show the other. Other solution. So you can go to add-ons here. You can go to manage add-ons, and then you can you'll find some add-on called phased array, right? You can find some add-on called phased array. So yeah, I'll just search here. So yeah, so this is the toolbox. This is actually what's sort of shadowing whatever we are typing, right? So you can go click here and uninstall this, right? But I mean, we won't need this, right? I have never used this phased array system toolbox up to date, right? But by any chance, if you probably need it, then it's another hassle, no? So what you can do is you don't have to uninstall this. So you simply can, oh yeah, I mean, it's an option, right? It's an option that you can try. But what I'm recommending is you can go to set path here. You can go to home and then click on set path, and you can see if I enlarge this, your robotics toolkit, add-ons probably might be down here, right? So so what you can do is for these robotics toolbox, because these are the priority order, right? So when you are running, say if say we have like repeated functions, like the rotational robotics function can be overshadowed or repeated in some other add-on. The priority order is always given from top to bottom, right? It's sequential, right? So so what you can do is you can give the priority order to these. So basically these are mobile robotics simulation toolboxes. Our concern is mainly about this robotics toolbox from MATLAB. This is our toolbox, right? So the spatial math is what the rotational matrices and all these things are included, right? So you can click on these here. Can click on these robotics toolbox for MATLAB. Folders or add-ons, and you can click on move to top here, right? Then they will be moved to the top in the priority order, right? So you can see that these are now on the top. So the priority order has been given to these add-ons or these folders, right? So you can save this. Make sure that you save it, right? If not, this is not going to save, and this is not going to be set as a priority. And now you type in the same function with the same angle, right? So you are basically finding the rotational matrix around the x-axis by an angle of 90 degrees. Now you will get the correct answer. This is what you're supposed to get, right? You can manually compute this and see if you can just, the rotational matrix, the equation, you can simply plug in 90 degrees or radians. In that case, you can calculate that using your calculator and see the answer that you get. And this is what you're supposed to get, right? Not this. So if this is coming, then of course your robotics toolbox is properly installed, right? So if you want to say use radians, I mean degrees, there's a way for that. You can simply put a D. Say if you want to use if you want to use sine 90, you can put a D here, right? And so that specifies degrees, and then you put 90, and you will get the answer as 1, which is the correct answer. But this is a hassle, right? So what I recommend is for you to simply go with radians, right? So it's easier, and it's like doesn't cause any problem. So if you just go with vertex T and put 90 here, it will not work, right? So, and if you put vertex 90, you will get this answer, which is completely wrong, right? So you are supposed to get this. So what you will have to do, you will have to manually develop all the rotation matrices and as an array, and then it's not going to work, right? It's going to cause you a lot of trouble. So you can simply work with radians, right? So this is it for the installation and setting up. So if you come across any issues while setting this up, I don't think you will, because this is pretty simple, right? It's very straightforward. But if you come across any issues, you can always contact me. So I will add a separate video on the example that we tried in class. I will sort of go through it once again. And then I will write the program and we'll see how it's computed. So I will stop this for now.